Hello viewers, this is Dr. Rajalakshmi, Associate Professor from Computer Science and Engineering Department of RMD Engineering College. In today's session, we are going to see about multithreading in Java. A thread is a lightweight subprocess, the smallest unit of processing. Multiprocessing and multithreading both are used to achieve multitasking. However, we use multi-threading than multiprocessing because threads use a shared memory area. They don't allocate separate memory area, so saves memory and context switching between the threads takes place less time than process. These are the examples, some of the examples of multi-threading. Computer games are best examples of multi-threading. You might have seen that in most of the race games, other cars or bikes will be competing with your car or bike. These are nothing but threads. Another example is MS Word document. When you start typing in a MS Word document, you can see that the incorrectly spelled words are underlined with a red wavy line. This is done by spell check feature of MS Word. The spell check is running in parallel while we type in a Word document. This is handled by a separate thread. Now let's see the difference between multitasking and multi-threading. Before seeing that, we'll see the advantages of Java multi-threading. Java multi-threading, it doesn't block the user because threads are independent and you can perform multiple operations at the same time. You can perform many operations together, so it saves time. Threads are independent, so it doesn't affect other threads if an exception occurs in a single thread. Actually, multitasking is a process of executing multiple tasks simultaneously. We use multitasking to utilize the CPU. Multitasking can be achieved in two ways. One is process-based multitasking called multiprocessing, and another one is thread-based multitasking called multithreading. Process-based multitasking is otherwise called as multiprocessing. Here, in this case, each process has an address in memory. In other words, each process allocates a separate memory area. So the process is heavyweight. So cost of communication between the process is high. Switching from one process to another requires some time for saving and loading registers, memory maps, updating lists, etc. Whereas thread-based multitasking, threads share the same address space. A thread is lightweight, so cost of communication between the thread is low. What's a thread actually? A thread is a lightweight subprocess, the smallest unit of processing. It is a separate path of execution. Threads are independent. If there occurs exception in one thread, it does not affect other threads. It uses a shared memory area. So this is the diagrammatic representation for single thread application. Statements are executed one at a time in an appropriate sequence depending on program flow. One statement must finish execution before the next statement can begin execution. And this shows concurrency in Java. When each multi-thread worker is started, it is executed in its own thread, independent of the main thread. This application has total of 4 application threads, and all the threads can execute independently. Now let's see about Java multi-threading model. The thread class. Java's multi-threading feature is built into the thread class. This is the thread class hierarchy. The Java thread class is available under java.lang.object class. And actually it implements a runnable interface. Actually, Java provides this thread class to achieve thread programming. The thread class provides constructors and methods to create and perform operations on a thread. Thread class extends object class and it implements a runnable interface. The following are the important methods available in thread class. The very first method is start method. It is used to start the execution of the thread. And the next method is run method. It is used to do an action for a thread. Actually, it performs the work of the thread, and this is what is the entry point for the thread. The thread dies when the run method terminates. You never call run method explicitly. Whenever the start method is called, run method will be invoked automatically. This is the thread life cycle. So whenever a thread is created, it will be in the new state. Then when the start method is invoked, it will enter the runnable state. If a thread is acquiring block, it reaches the block state. Once the block is acquired, it comes back to the runnable state. And when a thread is waiting for notification, it enters the waiting state. And once the notification is acquired, it comes back to the runnable state. When a thread is waiting for time out notification, it reaches time waiting state. And once the time is notification occurred, it comes back to the runnable state. Once the run method is completed, it reaches the terminated state. So this is the life cycle of the thread in Java. Now, these are the various methods in Java. Thread methods in Java. The methods are get name, get priority. Other than the start and run method, we have these methods also. Okay, so that is join method is available. Set name method, it changes name of this thread to be equal to the argument name. Then sleep method is there. It causes the currently executing thread to sleep for a specified number of milliseconds. And then start method, as we have seen already, it causes the thread to begin execution. Okay, then yield method, it causes the currently executing thread object to temporarily pass and allow other threads to execute. Current thread is a method. It returns a reference to the currently executing thread object. And these are the constructors available in the thread class. Thread without argument, thread with a string variable as an argument, thread with the runnable object as an argument, and then the fourth constructor is having two arguments. So the main method, when a Java program starts executing, the main thread begins running. The main thread is immediately created when main commences execution. Information about the main or any thread can be accessed by obtaining a reference to the thread using a public static method in the thread class called current thread. This is an example program for obtaining thread specific information. A new thread is created, and through that particular thread, we are calling the current thread method. So we will be getting information about the current thread, and that is available in T. Then afterwards, we are calling set name method with respect to the thread object T. So the name of the thread will become demo thread. So when you print the name of the thread, you'll be getting demo thread as the answer. Then, now we are going to see about creating threads. We have two approaches for creating a thread. One is by implementing the runnable interface. Another one is by extending the thread class. So this is the syntax for creating a thread by implementing runnable interface. Thread can be created by creating a class which implements a runnable interface. Then the thread class defines several constructors, one of which is thread runnable object, comma, string. In this constructor, thread OB is an instance of the class implementing the runnable interface, and it ensures that the thread is associated with the run method of the object implementing runnable. String thread name, we associate a name with this thread. Creating a thread does not mean that it will automatically start executing. A thread will not start executing until you call its start method. The start method in turn initiates a call to run method. Let's see a simple example for creating a thread using a runnable interface. It's a very simple demo for creating threads by implementing runnable interface. So name of the class is thread demo and it implements runnable interface. Inside this class, we are defining a method. Name of the method is run. So it contains the set of statements to be executed. We have a for loop inside this run method. Now, inside the main method, we are creating a thread object using this new operator. Then, once the thread object is created, we are calling the start method through that particular thread object. So whenever the start method is initiated, the run method will be called automatically and the code that are available inside the run method will get executed. This for loop will get executed. So this is the output of this program. Now let's see the second example, creating threads using extending thread method. We can also create threads by extending the thread class. Actually, to instantiate the class that extends thread, this class must override a run method. The code that should run as a thread will be part of this run method. We must call the start method on this thread. Start in turn calls the thread's run method. This is the example. The name of the class is thread demo and it is extending the thread class. And the thread is created by creating an object for this particular class, thread demo 1. Thank you.